voltage of 240 sin 377t is applied to a 6 ohm resistor. Find the instantaneous current, phase angle, impedance, instant power, average power and power factor. So first this is how the circuit does. So it is a AC voltage and it is given to a 6 ohm resistor. So it is nothing but I can term it as VT. So to find the impedance Z is equal to R, and that value is equal to 6 ohm, because we don't have any capacitor and inductor. So next we will find about phase angle. Okay, so to find phase angle, that is phi. Since I have only resistor, the phase angle value is 0. So therefore the power factor value is cos phi. Right? What is cos phi? Cos phi value is equal to 1. That is equal to 1. Cos 0 is 1. Okay. So which means what it represents, the V is equal to I. Okay. Next, instantaneous current, I of t. So to find instantaneous current, you have to divide instantaneous voltage by a resistor. And instantaneous voltage divided by resistance. So that is equal to 240 sin 377 t divided by R. R value is 6. So you will get 40 sin 377 t. So next, if I want to find the instantaneous power is equal to instantaneous voltage into instantaneous current. So we know that instantaneous voltage is 240 sin 240 into 40 sin square 377 t. Okay, so what is 240 into 4, 9600 sin square 377 t. So next I need to find the average power. So average power formula is Vm Im divided by 2 into cos phi. Okay, here cos phi value is 1, right? Because phase angle is 0. So cos phi is 1. So what is Vm? Vm is 240 and Im is 40. That is divided by 2. So we will get 4,800. The unit is watts. Now let us go for the second problem. So here pure inductive. Pure inductive means here there is no resistor and capacitor. Okay, so the pure inductance L value is 0.01 Henry. Henry is a unit which takes current I of t is equal to 10 cos 1500 t. Calculate the inductive reactance, first one, and voltage across the inductance, and what we can see will the inductive reactance will be equal to 40 ohm. So XL for inductive reactance, XL is equal to omega L. Omega value is 1500 into 0.01, that is equal to 15 ohm. Next, to find the voltage across the inductance, VL is equal to L di by dt. So that is the formula. So L value is 0.01 into di by dt is 10 cos 1500 t. So if I differentiate this one with respect to t, I will get 0.1 sine 1500 t into 1500. So it should be minus, right? So we will get 150 sine 1500 t minus 150. So next, at what frequency will be the inductor reactance will be equal to 40 ohm. So XL should be equal to 40. So okay. So 40 I can write that is equal to omega L. Okay, 40 is equal to omega L. So omega L I can write it as 2 pi f into L, right? So L is equal to 40 divided by 2 pi f. Okay. So f value, what is f value? So 0.01, it is equal to 20 divided by pi f. So what is f value now? 2000 divided by pi. So that is equal to 6.27, sorry, 37 hertz. Sorry, 637 hertz. So next, the third problem. If inductance value is equal to 0.225 Henry is connected to a 120 volt supply which is having a 50 hertz as a frequency. So here the 120 volts represent VRMS. Calculate the inductive reactance, that is XL. That is equal to omega L. So 2 pi f L. So L value is 0.225. So 2 pi into f value is 50 hertz. So you substitute the value and find the answer is 70.68 ohm. So the second question is so here since it is only inductor is connected, average power, okay, average power is equal to 0. Okay, because cos 90 value is 0. Okay, phi value is 90, that is phase angle is 90. Therefore cos 90, that is power factor is equal to 0. Okay, so average power is equal to 0. Power factor is 0. Okay, so we know that Vt is equal to Vm sin omega t. I am going to take Vt is equal to Vm sin omega t. So if we take civil for inductance, voltage leads the current. Okay, that means current lags the voltage by 90 degree. Okay, so if Vt is equal to Vm sin omega t, I can write I of t is equal to Im sin omega t minus pi by 2. It is lagging by, current is lagging by pi by 2. This I can write it as minus Im, okay, minus Im sin pi by 2 minus omega t. Okay, I can write it like this. So this sin pi by 2 is nothing but cos. If sin pi by 2 is cos and Minus means it goes to the first quadrant, so it does nothing but minus I of t is equal to minus Im cos omega t. Okay, so instantaneous voltage is Vm cos omega t, and instantaneous current is minus Im cos omega t. So instantaneous power is equal to Vt into It. So that is equal to Vt is equal to Im sin omega t. Okay, so minus Vm Im cos omega t into sin omega t. So this is something but your instantaneous power. So we know that Vrm is equal to 240. So Vrm is equal to Vm by 2 root 2. So Vm is equal to 240 into root 2. That is equal to 169.71 in volts. So Im is equal to Vm, Im into WL, omega L is equal to Vm. So Im is equal to Vm divided by omega L. So that answer we already know. Okay, so you substitute that value 2.4 amps. Okay, so you substitute on the instantaneous power value. So if I want to find the maximum power is nothing but an apparent power, that is nothing but Vm Im divided by 2. Okay, that is equal to 2.4 into 169.71 divided by 2, that is equal to 203.74 in watts. Okay, so instantaneous voltage is equal to 169.71 sin 2 pi into Fs 50 t, and instantaneous current is equal to minus 2.4 cos 2 pi into 50 t. Okay.